Hi, this video is going to go over independence. So two events are independent when knowing that one event has occurred does not change the likelihood that the second event has occurred. And two events are dependent when knowing that one event has occurred changes the likelihood that the second event will occur. For example, I'm thinking about going to get my car washed. However, if it's raining tomorrow, I'm not going to go get my car washed if it's raining because then it's going to get dirty all over again. So getting my car washed and the probability of it raining are two dependent events because if it rains or not, that's going to affect my decision to get my car washed. However, getting my car washed and you eating dinner tonight are two independent events because you eating dinner does not affect my decision to go get my car washed. So there's actually a formula to prove whether two events are independent or not. And that formula is that the probability of A given B is equal to the probability of A. So B, remember, is your condition. And what this formula is saying that if your probability was originally 60% for me to go get my car washed, then whether you eat dinner or not, the probability of my car getting washed should still be 60% because the condition that you eat dinner should have no effect. So if these two events are equal, then they are independent. However, if the condition changes the probability of A, then they are dependent. So maybe my probability of getting the car wash is 60%, but my probability of getting the car wash given it's raining is 0. So the raining changed the probability, and that means you're dependent. And we have this a lot in word problems. So let's look at the first one. As we read it, we're going to write out what we have. Sean's team has a baseball game tomorrow. He pitches 50% of the game. So the probability of pitching is 0.5. There is a 40% chance of rain during the game tomorrow. The probability of rain equals 0.4. If the probability that it rains, given that Sean pitches, is 40%, it could be concluded that these two events are. So I see a keyword given, and you underline what comes after. So this is my condition is pitching. What about it pitching? Probability of it raining is 0.4. Now let's look at the answer choices. They are asking for independent, dependent, mutually exclusive, and complements. So if you don't remember, a complement is the probability of something happening and the probability of something not happening. Mutually exclusive means that they can't happen at the same time. Now, Sean can pitch and it could be raining, so they are not mutually exclusive. When you see these problems of something being basically opposites, it's either independent or dependent, it's one or the other. The other options are irrelevant. It has to be one or two. And if you think about it, in this problem, we have independent versus dependence. We're going to use the formula. The probability of A given B equals the probability of A. If it's equal, it's independent. What do we have? We have the probability of rain given he pitches equals whatever comes first is by itself, the probability of it raining. And if you think about it, does him pitching affect whether it's raining or not? That doesn't make sense, right? They seem to be independent of each other. But the actual math is the probability of raining, given that it pitches, is 0.4. The probability of just raining is 0.4. So the fact that he was pitching had no effect. It did not change the probability, meaning they are independent. Let's try another one. According to the survey, the following information was determined. The probability that a student's favorite subject was English was 0.37. So probability English, that was written terribly, equals 0.37. The probability that a randomly selected student who is male had a favorite subject of English was 35. So this is conditional probability. It's the condition that you are a male and that you like English. That is 0.35. Our being a male and having a favorite subject of English, independent events. So as soon as it says independence, you know the formula is probability of A given B equals the probability of A. We have the probability of English given you are a male. What comes first has to be by itself. So we're going to set this equal to the probability of English. And we're going to ask ourselves, does being a male change the probability of you liking English? Well, we have the probability of English given male is 0.35. This is not equal to the probability of liking English. So clearly, this fact that you are choosing from someone who is male altered the probability of liking English. They're no longer equal to each other. So we would say that this is dependent. You could also say not independent if you prefer. Now it does say explain your answer. You would say dependent because the condition of choosing a male changed the probability of liking English. Okay, on to the next one. A fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses the drive-thru, and F, that a customer orders French fries, are independent. Anytime it says independent, know that you can possibly use this formula. You want to write it on the side in case we need it. Now they give us the probability of F. They give us the probability of F and D. They want probability of F given D. Now, we have two formulas for conditional probability. We know that we have the formula that conditional probability is the probability of F and D divided by the probability of D. Because remember that goes in the condition goes in the denominator. We also have the independence formula, which we are allowed to use because it says independence. So that is the probability of F given D equals the probability of just F, because we don't want the condition to change the probability of liking fries. And you have to ask yourself, which formulas or what information are we given? So we are given the probability of F, and we're given the probability of F and D. Clearly, we don't have enough information to use the first formula. We do not know the probability of D. So we are forced to use this one. We know the probability of, what is this, French fries, is 0.8. And because they are independent, that must be the probability of fries given drive-thru. All right, why don't you guys try one on your own? You could resume the video to see if you got your answer right or not. All right, I've listed what we had, the probability of activity and the probability of activity given you're a female. They asked if they're independent. So on the right-hand side, I used the conditional independence formula. Turns out that they are both 0.4. Being a female did not change the probability of being in an activity. So they are independent of each other. Just make sure you write that sentence because it does say explain.